right? So in the last lesson, we had to simplify square roots and cubed roots of numbers, right? This lesson is about, we've got to simplify square roots only, not cubed roots, of expressions, so it might have some variables in it. Okay. So let's figure out, how do you take the square root of a variable? Well, compare that with, I think I'm there. Let's say if I wanted to take the square root of 4, right, I could write that like the square root of 2 squared. And when you take the square root of a square, you get the number, right? The square root of 4 is 2. Well, the same way, the square root of x squared is x, right? When you take the square root of a square, those are inverse operations. They undo each other, right? So the square root of x squared is x. Now, if I take the square root of x to the 4th, I could write that like x squared squared because of the properties of exponents. What do you do when you raise a power to a power? What's the operation? This is on your quiz today. It's a multiply, right? So x squared squared is the same thing as x to the 4th. But now we're taking the square root of a square. So that's x squared, right? The square root, that's what this symbol is. And then what is it that's being squared here? X squared, right? So that's the answer. So the square root of x to the 4th is x squared. Okay, look at x to the 6th. I can write x to the 6th as x to the 3rd squared. So what is it that's being squared? X to the 3rd, so the answer is x to the 3rd. Did you have fun? Okay. Now, honestly, when I look at these things, the way I usually think of it, especially because I usually do this with Algebra 2, and we do have to do cube roots and 4th roots and all those kinds of things, there is a number that's in the hook of that radical symbol. It's invisible. It's assumed, right? If you don't see a number there, it's a 2. So I go, 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is x to the 4th, right? I mean, I could rewrite it as x to the 4th squared, but in the end, it's going to be x to the 4th. Just divide the power by the index, which is invisible. It's a 2. How about x to the 10th? Right? 10 divided by this invisible 2 is 5. So this is the equivalent of when we were taking the square root of perfect squares. All these things are perfect squares, right? Why are they perfect squares? Because their exponents are even numbers. So when you look at them, you know you're going to be able to take all the x's out. I hope so. Okay, so that's one variable that where all the expressions were perfect squares. Okay, now let's combine that with, okay, we've got our perfect squares of variables, and we also got some numbers, right? So the square root of 4x squared, we know what the square root of 4 is. That's 2, right? And then the square root of x squared is x. So just deal with the number separate from the variable. Okay, now look at the next one, right? The square root of 18x squared. Clearly, we can simplify the square root of x squared, but what about the square root of 18?
Divided by 2.
Okay, remember, this is like the homework we just finished doing, right? The square 18 is not a perfect square, but does it have any factors that are perfect squares?
Yes.
What? 9. So you need to simplify the square root of 18 part, right? That is, this is going to be the square root of 9 times the square root of 2 times the square root of x squared. Just split them up. And then the square root of 9 is 3. The square root of x squared is x. And then the square root of 2 you can't simplify. So the things that you can simplify go in front of the radical, and then whatever you couldn't simplify just stays inside. So what's that? Yes, because again, you can simplify the square root of x squared as an x on the outside. No radical involved. I guess I had already done that here. So try to simplify that one. Remember, we did the square root of 96 a few times. You know, we did this, right? You still have those pages right there, right? So you can say this part of it only is 4 times the square root of 6. And then what's the square root of x to the 4th? X squared, right? So where do you put the x squared? It goes right in front of the radical, right there. You know, it looks better if we did it, space it out. 4x squared times the square root of 6. There's actually a lot. Which question?
I don't get like the x part. How do you get it?
Well, remember, like we said, the square root of a perfect square cancels each other out, right? If I said the square root of 25 is the square root of 5 squared, so that's 5, right? In the same way, the square root of x squared is x. Anytime you take the square root of a perfect square, they cancel each other out, and you just get that thing. I hit the top of the pen there. So the key is, if you can write what's inside the radical as something squared, then you can take it out. Now, if x to the 4th, right, x to the 4th is not written as something squared, but we could rewrite it like x squared squared, because that equals x to the 4th. And now, what is the thing that's being squared? X squared. So that's how it simplifies. Right? Now, there's actually a few caveats, there's a lot of qualifications to what we're actually trying to do here, which is not much, right? We only have to try to simplify what you call a monomial expression. Monomial means one term, right? So what you see inside the radicals that we simplify here, there's not like a plus or a minus. That would make it more than one term. So it's just one term. It's just what you would call the principal square root, because, for example, the square root of 25, right, would be the number that multiplies times itself to give you 25. Okay, that would be 5. But it would also be negative 5, right? Wouldn't negative 5 times negative 5 also be 25, right? Because negative times negative, cancels, makes a positive. But principal square root means you only have to worry about the positive. So we don't have to worry about that. And the second thing is we can assume that all of our variables are always positive. So we don't have to worry about like square roots of negative numbers or absolute value symbols or anything. We just have to worry about simplifying one term inside of a radical, no other complications. And how much complications could there be? You could have a number involved, and you could have some variables involved, right? And we'll have more than just one variable by the time we get done with this. So now, what's going to happen if I have like x to the 3rd, right? Can I write x to the 3rd as something squared? And the answer is no. But what I can do, just like with the square root of 96 was not a perfect square, so I split it up into 16 times 6. Well, here I can split this up into x squared times x. Properties of exponent says, right, that's x squared times x, you add the exponents and you get 3. So I'm using the properties of exponents to break it up into two different radicals. Now the one radical is the square root of a perfect square, so I can simplify it. And the other one is not, so I can't, right? So the square root of x squared is here, and times the square root of x. I can't simplify it because there's not a perfect square inside. I mean, look at the x to the fifth, right? X to the fifth, again, what I do is I would go like this. I would say 5 divided by 2 doesn't go evenly. So I've got to split this up somehow. Get some part of it that will simplify and some part that won't, right? So I'm going to break it up into the x to the fourth times x to the first. Is that the same thing as x to the fifth? Properties of exponent says that it is, right? 4 plus 1 is 5. And now the square root of x to the fourth, we know, right? How many x's come out? 2, right? Oh, and I didn't write down the square root symbol. That's a mistake. Uh-oh, that should have had that. Now, what if instead you said, okay, I'm going to split this up into x squared times x to the third. Okay, then I would have x times the square root of x to the third, right? But the square root of x to the third has to be simplified too, just like we did up there. So you always want to break it up into the most simplifying that you can. So like if this is x to the fifth, then break it up into x to the fourth times x to the first, right? Because that'll give you the most simplification possible, right? If you got to this point here, you wouldn't be done. You'd have to keep going. Okay. So try to simplify x to the seventh. Split it up into a part you can simplify and a part that won't. Questions? Sebastian? Any other suggestions? 6 and 1. Okay? Think of what's the highest even number less than 7? 6. Okay, that's going to get you the most simplification. So make it the square root of x to the 6 times the square root of x. And then how does the square root of x to the 6th simplify? How many x's are going to come out? 3, right? Again, 6 divided by the index of 2 tells you that 3 come out and 1 stays inside, like that. Okay, now what if we have more than one variable inside? Then you just have to repeat this, think individually for each variable. Like the square root of x squared y squared. When I was just doing x squared, the square root of x squared was x. Okay? Okay, what would the square root of y squared be? Y. That's it. Right? Just deal with each variable individually. Do I need to, this square root of x to the third y squared, am I going to be able to simplify this and take everything outside the radical? Trinity? Yeah, x to the third isn't all going to come out, right? I got to split that one up. The y squared is good because it's an even exponent, but the y to the third, or x to the third, I got to do something about. So how about we split that up into x squared times the square root of x times the square root of y squared. Right. Now the square root of x squared is x. The square root of y squared is, and then the square root of x we can't simplify. Right. So this goes here, this goes here, and then this stays the same. Okay, well, what do you think the next one will look like if it's the square root of x to the third and y to the third? Yeah, I mean, you can split it up, right? This can be the square root of x squared times the square root of x times the square root of y squared times the square root of y, right? And that's x times the square root of x, y times the square root of y, but we would write that like x, y times the square root of x, y. So you just get, think of it like you're looking through a straw. Just look at the one variable, deal with it, right? Then look at the other variable and deal with it. And if there's a number, deal with it, right? But don't try to make it too complicated. So you look in the first step, you look at it and say, oh, that's too much, I can't even start, right? How about this one? The square root of x to the 5th, y to the 8th. Which one of those do I need to split up so I can simplify part of it? Right? Which one has an odd exponent? X to the 5th, right? So how am I going to split that up so I can simplify some part of it? X to the 4th times square root of x, and then the square root of y to the 8th. That should all simplify, right? What's the square root of x to the 4th?
X squared.
Okay. And what's the square root of y to the 8th?
X
Y to the 4th, right? 8 divided by 2, 4. Okay, and then the square root of x you can't simplify. But again, you should write it with what's outside the radical should all go in front of the radical. Done. Okay, I don't even remember what I got in here. So try that one. So, I mean, what's the easiest part of this simplifying? What's z to the 0? 1. So basically that goes away, right? You don't have to deal with anything to the 0 power is 1, right? And 1 times anything is the same, identity property. So I can just write this like the square root of x to the 6th, y to the 3rd. Right? Don't worry about something to the 0 power. It goes away, right? Okay, then deal with that. Not correct. Yeah, because remember, this is going to be the square root of y squared times y, right? And the square root of y squared is just 1y. And then what's left is y. Just like that. Okay. You should put it in front. What's outside the radical needs to be like a coefficient in front. Okay. Okay, how about this one? Well, I have to do something about the square root of 25, or can I simplify the square root of 25? It's a perfect square, right? How about the x to the 5th? Do I need to split that up? And how about the y squared? No, that'll simplify. So let's write it like this. The square root of 25, which I won't have to simplify. And then how am I going to split up x to the 5th again? X to the 4th times the square root of x, and then the square root of y squared. Okay, what's the square root of 25? 5. The square root of x to the 4th? X squared. The square root of x we can't simplify, and the square root of y squared is y. So then just move everything in front of the radical. 5x squared y times the square root of x. No? Properties of exponents and scientific notation. Okay, we're not done yet. Not done yet. Okay, how about this one? Quiet, please. The longer this takes, the less quiz time, okay? Okay, how about square root of 50? Is that a perfect square? So how am I going to split that up into, like what we did with the homework? Say again? That would be 49 plus 1. We're looking for factors. 5 times 10. Neither 5 or 10 is a perfect square. What is a factor of 50? 25, right? You could say 25 times 2. Again, every time we do this, we're not going to go to the calculator and make a table of values in that. I mean, we got to think 50 times 25, right? Or 50 equals 25 times 2. So let's make this a 25 times 2. How about the x to the fifth? How should we split that up? X to the fourth times x to the first, right? How about the y to the third? Y squared times y to the first. So now we can take the square root of every one of those. What's the square root of 25? Square root of 2? Can't be simplified, right? It's not a perfect square, so you just have to leave it. How about the square root of x to the fourth? X squared. How about the square root of x? It's not the square root of a perfect square, so it has to stay. Okay? The square root of y squared. And the square root of y. Can't do it. Okay, so now put all the things that are outside the radical together in front of the radical. 5x squared y. And then put all the things that are inside radicals inside the same radical, 2xy. Right. I took all the things that were outside radicals and I put them front. And I put all the things that are inside radicals inside radical. Get it, Victoria? Yeah. In a minute. So try that one. Again, there's the 96 that we did before. So again, what was the square root of 96? We did this. 4 times the square root of 6, right? So that part I'm going to leave alone. 4 times the square root of 6, right? How are we going to split up the x to the 7th? 6 and 1. X to the 6th times x to the 1st. How about the y to the 10th? Can we take them all out? It's okay, right? It's an even number, so we can leave that. And then y and z squared. So we're going to take the square root of all of these things, right? What is the square root of x to the 6th? X to the 3rd. And the square root of x? Leave it. The square root of y to the 10th? Y to the 5th. And the square root of z squared? Z. So now put all the things that are outside the radical in front of the radical. 4x to the 3rd. Y to the 5th. Z. And then all the things that are inside radicals, put them together in one radical. That's about as complicated as it gets at this level. Okay. So that's the end. And you have a worksheet to do for homework.